Hey y'all, and welcome to videos for lesson 6. Today we're going to be talking about multidimensional NumPy arrays, dictionaries, and datetime. So as usual, this lesson is going to be divided into a few different parts. We're going to have multidimensional arrays where we're going to be talking about how those are structured and formed. Then we're going to get into more array functions, particularly the things we can do with multidimensional arrays. And then we're going to talk about dictionaries and datetime, both of which are important objects and functions for data analysis in Python. I still encourage you all to take breaks in between these videos and pause as needed, just to keep your brains fresh as you're going along. Jumping right in, we have multidimensional arrays. And I want to start us off with this slide here. So this was the same slide that Ethan used in the previous lesson. And I really want to emphasize it because in order to do anything with these NumPy arrays or NumPy functions, we have to have this import statement at the top. So we have to have import NumPy as NP in order to make any of these things work. In all of my examples through this lecture here, I don't have this in the example, and that's because I've assumed at the top of my code I have it and it's already run and it's loaded in. So be aware of that and make sure that you have it in your code as well. Next, I want to show this, which is also from Ethan's previous lesson, and it was his example for forming a simple one-dimensional NumPy array. So you have np.array, and then you feed it 5, 6, 7, 8 in a list. And that's how you form a nice, simple one-dimensional array using this np.array function. Now, that's great, and you can put numbers in it, and you can use data analysis on it. But if you notice, the definition of this NumPy array is really an n-dimensional array. So you can have one dimensions like this, or you can have more. You can have 2, 3, 4, however many dimensions your heart desires. Which means that we have to talk about those cases and some of the nuances that happen and some of the cool things you can do. So let's start with the two-dimensional case. Here we have np.array, it's the same function, and we feed it a list, right? So we have a list, and inside of that list, we have other list objects, right? So that is, again, a list within a list. We have these outer brackets and these inner brackets, and the outer list has 2 list items within. So when you plug that in, you get something that prints out sort of like this. You notice right away that this prints out differently than a list of lists would. So it prints out in this sort of structure here, and it gives you these rows, 1, 2, 3, 4, 5, 6, 7, 8, and it gives you these columns, 1, 5, 2, 6, 3, 7, and 4, 8. So with these rows and columns, it's created this sort of more structured array that makes it easier for us to find our data as we go along. If you give a single number index, it gives the items of the outer list. So that's very similar to a list of lists, right? We say A of 0, and we get that first item, which is 1, 2, 3, 4. And that's the same thing as a list of lists. But here's the neat part. When you want to select a single specific item, you can actually use the row and column index values in order to select it. So in this example here, we have A of 0, 0. And what that is saying is to say A of the 0 row here and the 0 column here, right? So where those intersect, that's our number. And that's 1. So again, we have A of 1, 0. So that's saying the 1 row and the 0 column. So 1 row, 0 column, and that's 5 right there. The next example, A of 0, 1, right? So row 0, comma, column 1. So row 0, column 1, that's 2. And then finally, A of 0, 3, right? Row 0, comma, column 3. So row 0, column 3, and that's 4. So that's a pretty neat way of doing it. And that's a handy way of structuring your data because a lot of times you'll have different columns being different variables, and you want to be able to link things together as you go. You can also slice and select specific rows or specific columns. So here in this example, we have A of 0, comma, colon 2. So we have row 0, comma, colon 2. And what that's doing is it's taking these columns as a slice. So it's saying colon 2. So it's saying start at the beginning and go up to and not including 2. So what that's doing is row 0, column 1. So that is 1 and 2 right there. The next example, A of colon, comma 1. What that's saying is take all of the rows. That's what that colon does, comma 1. And that says just take the 1 column. So it takes all of the rows, both 0 and 1, and it just takes the 1 column, and that's 2 and 6, just like that. So that's a pretty neat way of being able to select out specific bits of your data in order to analyze it better or to pick out specific parts that you want to look at. So that's the two-dimensional case. Next, we're going to talk about the three-dimensional case. Now, I know this looks a little bit ugly, so we're going to break it down a little bit. We have this outer brackets in green here, right? So we're feeding this np.array still just one list item. And then we have these middle brackets shown in red here. And you see it creates these two items within this outer list as these inner lists. And then the middle lists have more lists inside with these inner brackets, and that splits it up into these groups here. So when you type this all out and plug it into Python in order to run, you get something that looks a little bit like this when it prints out. What this is doing is saying that it has two layers, layer 0, layer 1, with 2 rows and 4 columns each. So it has 2 rows each and 4 columns each, right? So whenever you're trying to get numbers out of that, you have to account for all of these dimensions. You have to account for the layers, the rows, and the columns. So the order of that is layer, row, column. So when you select out a specific value, it's print b of 0, 1, 3. So here, b of 0, that's layer 0, right? So that's this layer here, comma 1, so that's row 1. So row 0, row 1 here, and that would be column 3, right? So column 0, 1, 2, 3, and that gives us our answer of 8. So that's the case for the three-dimensional array. You can slice, you can index in the same way as the two-dimensional array. It just has that added layer dimension. So that's all I want to talk about for multi-dimensional arrays and how they're formed and structured. You can create arrays with more dimensions, and you just sort of have to keep thinking about indexing and how those things relate to each other. Most of the time in oceanography and in earth science data, you're going to end up with a two-dimensional array is most common. Sometimes you'll get a three-dimensional array if you're looking at things in time or if there's like a depth component. And then very, very rarely will you get a four-dimensional array. And oftentimes when you do, there's going to be a better option. So I don't want to push on that too hard. So that's the end of this video. We're going to talk about more array functions and sort of the ways that we can manipulate those multidimensional arrays in order to do what we want to do. See you soon.